There is a building in southern China that cost $1.2 billion to build. If you walked past it at midnight, you would think it was empty. The windows are black. The parking lot has no cars. There are no lights on inside. But the building is running at full speed right now. It has been running every second of every day for years. The place is called the Midea Smart Manufacturing Complex. It sits in Shunde, Guangdong Province. It does not use human workers on its production floor. It does not need them. It does not need electricity for lights or air conditioning for people. The machines inside put things together, weld parts, and move materials all day and all night. They never stop for a weekend. They never call in sick. The whole system works in total darkness because the technology guiding it does not need human eyes. China has been building places like this since 2015. The government program behind it is growing faster than anything in Germany, Japan, or the United States. If you work in manufacturing, or if your job depends on a company that makes physical products, this place already affects you. If you like videos like this, please hit the like button. It takes a lot of work to research and make these. And subscribe so you do not miss the next one. What is happening inside that dark building in Shunde is part of a big shift that surprised most of the world. To understand why a country would spend $1.2 billion on a factory with no lights, you need to start with the building itself and what is going on inside those walls. A factory in the dark. The Midea Smart Manufacturing Complex sits in Shunde. Shunde is a district in Guangdong Province that has made appliances and machine parts for decades. The facility cost $1.2 billion to build. From the street, it looks like any other big factory in the area. The one difference is clear at night. Every window is pitch black. There is no glow from inside. There are no floodlights over the loading docks. The facility has worked this way for over 3 years straight. Inside, the production floor has 0 people walking around. There are no forklift drivers. No bosses carrying clipboards. No workers eating lunch in a break room. The floor belongs entirely to robotic arms and self-driving vehicles that move materials between stations. These machines run 24 hours a day, 7 days a week, 365 days a year. They do not take holidays. They do not take vacation. They do not need the building heated or cooled to a nice temperature. The idea is called lights-out manufacturing. The name comes from a simple thought. You could turn off every light in the building, and production would keep going without stopping. The machines find their way using sensors that work perfectly in total darkness. They know where they are on the factory floor, with accuracy measured in tiny fractions of a centimeter. Raw metal enters the facility at one end. Finished parts come out the other end. Between those 2 points, no human hand ever touches the material. The machines pick up parts, move them to welding stations, put them together into bigger units, and send finished pieces to inspection zones. Every step is automated. Every choice about where to send a part next is made by software running on small computers attached to each machine. The Midea Complex is the facility that China points to when other countries ask what a fully certified smart factory looks like at full size. It is the flagship, but it did not appear overnight. It grew out of a smaller test in a nearby city. That test proved the idea could work before anyone spent $1.2 billion to make it bigger. That test started in 2015, and the story behind it shows why China moved so fast toward automation in the first place. The blueprint in Dongguan. Before the Midea complex existed, there was the Changying Precision Technology facility in Dongguan. Changying was the test run. It was the place where Chinese engineers tried to see if a factory could really work with nobody on the floor. Before the change, Changying operated like a normal factory. It had 650 people who ran machines, moved materials between workstations, checked finished parts, and managed the daily flow of production. Then the facility went through a huge change. The staff was cut from 650 down to just 60 people. Those 60 remaining workers do not touch any machines. They sit in monitoring rooms, looking at screens that show what the automated systems are doing. They are there to make sure the software stays online, not to run equipment. The production floor itself has no people at all. The results were huge. The facility said its total output tripled after the switch to automation. They were making 3 times as many finished parts as before, with about 1/10 of the staff. The quality numbers were just as striking. The defect rate fell to 0.01%. For comparison, a normal factory making similar parts usually sees defect rates between 1.5 and 3%, according to the American Society of Quality. That difference might sound small when you look at the raw percentages. But when you are making millions of parts, even a tiny fraction of a percent adds up to huge savings. Those savings show up directly when companies negotiate contracts. If your defect rate is 100 times lower than your competitors, you can offer better prices and still keep higher profits. The Changying facility finished its first full lights-out production cycle on September 22, 2015. That means the building ran non-stop with no human operators on the floor at any point. The facility reached full capacity in under a year. That timeline surprised European industrial planners. In Germany, setting up a new automated facility usually takes several years. The idea that a factory could go from first setup to full lights-out operation in under 12 months did not fit their models for how these projects work. Engineering publications covered the Changying result not as a curiosity, but as a repeatable pattern. The facility was not a one-time experiment. It was a blueprint. The success in Dongguan gave the Chinese government and private companies the confidence to invest at a much bigger scale. The Midea complex in Shunde was built using the same ideas, just made larger and more ambitious. But understanding why China felt the need to move this fast requires looking at the money pressure that was building behind the scenes. The old plan that had made China the manufacturing capital of the world was starting to fail, and time was running out. The math that forced a change. For 40 years, China was the place where the world made its stuff. The logic was simple. Chinese factory labor was cheap. If you needed to make a product at the lowest possible cost, you set up production in China. That math held steady for a whole generation. But by the early 2020s, the numbers were moving in a direction that threatened the whole model. According to data from the National Bureau of Statistics of China, manufacturing wages in the country rose about 300% over a 15-year period. That is a huge increase. It means a factory worker who cost a certain amount per month in 2006 was costing 4 times that amount by 2021. The price advantage that had drawn global companies to China was shrinking fast. Other countries in Southeast Asia, including Vietnam, Cambodia, and Indonesia, could offer wages that China could no longer match. If China kept competing mainly on cheap labor, it was going to lose. The leaders in Beijing saw this early. In May 2015, the State Council, working with the Chinese Academy of Engineering, released a policy document called Made in China 2025. The document laid out specific number targets for upgrading industry. Most Western economists read the document and said the goals were unrealistic and driven by politics. One of those targets dealt with robot density. That measures the number of industrial robots per 10,000 human workers. In 2015, China's robot density was 36. That was well below the global average at the time. The document set a target of 150 robots per 10,000 workers by 2020. Reaching that would mean roughly quadrupling the density in just 5 years. Most outside analysts thought the timeline was impossible. They were wrong by a lot. By 2022, China had reached 246 robots per 10,000 workers. They did not just meet the target. They beat it by 64%. The International Federation of Robotics put out a report in 2023 showing that China installed 290,258 industrial robots in 2022 alone. That number is bigger than the combined total of every other country on Earth. To make that number feel real, think about this. The city of Pittsburgh has about 300,000 residents. In a single year, China added nearly one fully working industrial robot for every person living in that city. The choice to push automation this hard was not only about wages, it was about getting rid of risk. Human workers bring things that machines do not. People get sick. People ask for more money. People quit and need to be replaced. People form groups to push for better conditions. People are affected by global health problems. Every one of those things can stop production. A lights-out facility running at full capacity can match or beat what 2,000 manual workers produce in a day. It runs every hour of every day with no extra pay for night shifts, no costs for replacing workers who quit, and no risk of pandemic shutdowns. The energy cost per unit also drops because the building no longer needs lights, heating, or cooling systems built for human comfort. China was not just trying to cut jobs. It was trying to build a manufacturing base that could not be stopped by anything a person might do. But committing to automation at that size required something else. China needed a huge supply of industrial robots, and the story of how it got them involves a purchase that shocked the global robotics industry. Buying the blueprint. The idea of running a factory without lights did not start in China. Japan had been doing it since 2001 at a Fanuc Corporation facility in Oshino, a small village in Yamanashi Prefecture. The engineers there treated it as an experiment to show what might be possible decades later. Chinese planners studied that experiment and came to a different conclusion. They believed the future did not require decades of waiting. It required building right away, and not just in one facility, but across dozens of sites that would eventually grow into hundreds. The problem was supply. In 2015, China bought more industrial robots from foreign companies than any other country. The machines it needed came mostly from overseas. The most advanced models were built by KUKA, a German company founded in Augsburg in 1898. KUKA was widely seen as one of the 3 best robotics makers in the world. Its products were used in car plants, precision assembly lines, and aerospace facilities across Europe and North America. Relying on imported robots for a national manufacturing change carried clear risks. If your whole industrial plan depends on equipment built in another country, you are open to supply problems, price changes, and political pressure. The Made in China 2025 document addressed this directly. It told Chinese companies to build their own robots inside China rather than keeping buying from foreign sellers. Building a domestic robotics industry from scratch would normally take 15 to 20 years of slow technology sharing, joint projects, and step-by-step learning. China chose not to wait. In 2016, Midea Group, a Chinese company best known for making air conditioners and home appliances, bought KUKA outright. The purchase cost 4.5 billion euros. An appliance maker had just acquired one of the most advanced robotics engineering companies on the planet. The deal confused financial experts. Major publications including the Wall Street Journal, Reuters, and Bloomberg covered the purchase with clear doubt. On paper, it looked like a mismatch. A company that made home appliances buying a German precision robotics firm seemed like a mistake. What the doubters did not understand was that Midea was not buying KUKA to keep making the same robots in the same German factories. They were buying the engineering knowledge. They were buying the designs. They were buying the manufacturing processes and the expertise that had taken KUKA over 100 years to build. The technology transfer that would have taken 20 years through slow licensing deals happened in a single purchase. The results became clear over the following 7 years. By 2023, robots made by Chinese companies, including Estun, Siasun, and Inovance, held about 36% of the Chinese domestic market. In 2015, before the KUKA purchase changed the landscape, that share was under 10%. Chinese companies had used the knowledge gained from KUKA to build their own competitive robot industry in less than 10 years. Midea did not just get robots, it got the blueprint to build them. With a domestic supply of industrial robots now available, the next challenge was putting them into facilities fast enough to matter on a global scale. That required a set of rules and approvals that most countries had never designed for this kind of factory. The rules of the game. Almost no Western analysis of China's automation strategy looks at the regulatory system that makes it possible. Think about a real example from Germany. In 2018, a mid-sized automotive parts maker in Baden-Württemberg started seeking approval to build a new automated production facility near Stuttgart. The company had the money. It had picked its equipment suppliers. It had found a specific site for construction. By 2023, 5 years later, construction had not started. The project was still working through a series of regulatory requirements. It needed an environmental impact study. It needed 2 separate rounds of zoning review. It needed union consultation, which is required under German laws that give worker representatives a voice in major company decisions. It needed grid connection approval from a regional electricity company. Each step was handled by a different government body. Each step ran on its own timeline. None of the steps happened at the same time. This is not a story about German incompetence or bad engineering. Germany makes some of the best industrial robots in the world. German manufacturing standards are respected everywhere. What Germany has is a governance system built around priorities that were set before lights-out manufacturing existed as a concept. Labor rights, environmental protection, and democratic accountability are built into the approval process. Those priorities matter, but they were designed for a world where factories hired thousands of people who needed safe conditions, fair pay, and a voice in how the facility ran. The regulatory system was never built to handle a facility that has no workers, runs at 3 a.m., and needs nothing for human comfort. China's designated smart manufacturing zones work under a totally different system. Local government approvals, national ministry certification, and physical construction all happen at the same time instead of one after another. The result is a timeline from getting land to first production that runs between 2 and 3 years in these zones. In the European equivalent, even under good conditions, the same process takes 5 to 10 years. The gap between the two approaches is not measured in technology. It is measured in calendar time. Western manufacturing executives are now trying to explain this to their boards of directors. The conversation is not about who has better robots. Germany built KUKA. Japan built Fanuc. The United States has deep capital markets that can fund large-scale projects. The technology gap is small. The regulatory gap is huge. A race that runs on approval timelines is one that Western nations have no built-in way to win at current speeds. That is a problem that cannot be solved by building a better robot arm. It requires changing governance systems, which is much harder and much slower than upgrading technology. China saw this early. It created special zones where the rules were rewritten to fit facilities that do not need human workers. The government made speed and parallel processing the priority. The result is a growing network of working lights-out factories that are already making goods, while similar projects in other countries stay stuck at different stages of approval. The competitive factor is shifting. It is no longer just about who has the best technology. It is about who can build the physical infrastructure to use that technology the fastest. China is answering that question right now, and the answer is visible in places like Shunde and Dongguan. The machines that debug themselves. If you stood at the entrance of the Changying facility in Dongguan at midnight, the first thing you would notice is sound. Not silence, sound. The building is full of machines running, but none of them make any concession to human presence. There are no warning beeps where hallways cross. There are no emergency lighting strips along the floor. There are no signs telling you where to walk or which areas to stay away from. The self-driving vehicles moving across the production floor produce no visible light at all. They navigate entirely through internal sensors that map their surroundings in real time. A reporter for MIT Technology Review visited a similar Midea lights-out facility and described the experience in a way that production numbers cannot capture. The strange part was not the darkness. It was the feeling of machines moving around you without knowing you were there. The systems did not slow down or change their routes because a human was standing in the space. From the machine's point of view, the human was just another object in the way. The system was not built to handle obstacles that move unpredictably. The facility works across several specialized zones. The machining area handles raw cutting work. Metal pieces enter this zone looking like rough cylinders. They come out the other side as precision parts cut to exact sizes. The whole change happens without any person touching the material. It works like a high-speed conveyor system for heavy industrial parts, where each item arrives in a raw state and exits fully shaped. The precision assembly zone works at tolerances measured in microns, which are units equal to 1/1,000,000th of a meter. At that scale, human hands cause tiny variations no matter how skilled the worker is. Robotic arms guided by optical feedback systems keep a level of consistency that human workers simply cannot match. Every finished part goes through three-dimensional optical scanning before it leaves the facility. Defect detection rates using this method are much higher than regular human visual inspection, according to benchmarks published by China's Ministry of Industry and Information Technology. The design feature that makes the facility tough is its edge computing layer. Each robotic system carries its own local processing power and runs on its own without depending on any central server. The factory does not need a constant network connection to keep working. If the network goes down, production keeps going. This fixed the single point of failure problem that had hurt earlier automation efforts, but it created a new challenge that nobody expected. When dozens of independent systems make routing and sequencing choices at the same time in close physical space, they create conflicts that the original software was not built to handle. Two machines might arrive at the same crossing from different directions at the same moment. A finished part might be needed in two different places at once. The Changying operations team spent more than a year of live production working out conflict resolution logic to fix these issues. They did not do this work in a lab. They did it by watching the deployed systems interact in real time and writing new rules based on what they saw. The factory literally debugged itself by running. That process points toward a future that is already taking shape. By 2030, China's Ministry of Industry and Information Technology projects that most large facilities in its designated smart manufacturing zones will meet lights-out certification standards. The Sichuan Corridor, which includes aerospace and precision parts manufacturing, is a priority target for that timeline. The engineers who designed Changying in 2014 have moved on to newer projects. Several of those projects involve systems that go beyond autonomous production into autonomous process improvement. These are facilities that study their own output data and change assembly sequences without any human input. That type of factory does not yet have a standard name in English. The direction of automated manufacturing is not in question. The real question is, what happens to the global economy when the key factor is no longer the cost of a human worker, but the cost and speed of building the automated system that replaces them, and how fast your government can approve the permits to build it? If this story caught your attention and you want to see more like it, hit the like button, subscribe to the channel, and turn on notifications so you never miss the next one. There are related videos on the screen right now if you want to keep watching. So here is something to think about. If you were running a factory that worked perfectly with no human workers on the floor, what would you choose to build inside it? Let me know in the comments.